Today I'm going to talk about water and the properties of water that are so important for sustaining life. This is a mosaic that I compiled of the various phases of water that are present on Earth. You can see water as its liquid form, you can see it as its solid form, or sometimes even as its gaseous form, like water vapor. It's found easily in the atmosphere. So water is the most abundant molecule in living organisms, and it's essential for organisms to maintain homeostasis, as well as to carry out some energy processing and metabolism. And what we're going to do today is look at the properties of water that are important for allowing it to function as a support for all living organisms. Now, the first thing I'd like to talk about, just briefly, a recap from the last video, is that water is a polar molecule. This is absolutely important because this polarity that water possesses allows it to have a slightly negative charge at one end where the oxygen is. Why is that negative at the oxygen end? Remember, oxygen is electronegative, which means it's pulling the electrons a little closer to itself. And on the other end of water, we see a partial positive charge, which is what hydrogen possesses. So hydrogen possesses that partial positive charge. This difference in charge across the water molecule makes it polar. And it's this difference in charge that allows it to form hydrogen bonds across individual molecules inside water. Okay, so these hydrogen bonds that form are really important for all of the properties of water itself. The first property I want to talk about is water is an excellent solvent. It's a really, really good solvent. And this simply means that water is good at dissolving things, simply put. This is an example of salt, sodium chloride, that's actively being dissolved in a beaker full of water, where the green and the yellow represent sodium chloride, and the red and the white represent the water molecules that are slowly chipping away at the sodium chloride. And this is a zoom in this region right here, where we see that water molecules are orienting themselves so that the negative end, which is the oxygen end, is facing the positive end of sodium, and that it can also orient itself so that the positive end of the molecules of water are facing the negative end of the chlorine. So water is really important at dissolving many substances, one being sodium chloride, and it's really good at dissolving other substances such as glucose. So a lot of other polar molecules can dissolve really, really well in water. So it's a really good solvent. Or it's also known as the solvent of life. So I'm going to call it that from here on out. So the other properties of water is high specific heat. So this means high specific heat is the amount of energy that must be put into the system, okay, that can change the temperature of that particular system. So, and when we're talking about system, we can talk about a solution. So it's the amount of energy that is required to change the temperature even just by 1 degree of water. So it's the amount of energy required to put into the system to change the temperature of the system. And water has a really high specific heat. So that means you need to add a lot of energy for you to change the temperature of water itself. And the reason why it takes a lot of energy is because, going back to the hydrogen bonds, so there's many hydrogen bonds in a glass full of water, for example. And when you apply energy to that glass of water, you have to break all of those hydrogen bonds for water to begin to evaporate. So it takes a lot of energy to break those bonds, and that's why water has a high specific heat. Okay, if you are familiar with boiling water, I think you probably are. This is an example, so I just have a question to ask you. What temperature does water turn to gas? You probably are thinking 100 degrees Celsius. It's 100 degrees Celsius, so it takes a lot of energy. And another thing to note is evaporative cooling, and I'm putting this up because I do want you to be aware that evaporative cooling is a major property of water, because when water evaporates, it can take with it a lot of heat as well. So it does take a lot of heat to boil water, but when water begins to evaporate, it can take a lot of heat with it as well. And evaporative cooling is important because when we exercise exercise rigorously, we begin to sweat a lot, and as the sweat begins to evaporate from our skin, we begin to cool off because that water that's evaporating from our skin will take with it a lot of heat. So the third major property of water that's really important to life is that when it turns to a solid, it actually is less dense than when it's in its liquid form. So ice floats. Everyone is aware of this. Now let's look at the actual structure of why that's true. Oh, before we do that, this is just a really big iceberg of water I wanted to show you. This is that example where we can see not ice just floating in your cup of water, but you see ice floating in nature. Although it's really sad because it's predicted that in the next 30 years or so, we're not going to have any more icebergs left because of climate change. Okay. So let's talk about the actual chemical structure of these water molecules when it gets a little cooler. So these two are diagrams of ice and liquid water. So these molecules are oriented in such a way when water becomes cool enough, these hydrogen bonds can order in this really pretty crystalline structure. So it organizes in this really pretty crystalline structure, and it's extremely stable. However, when you look at the liquid water molecules, you'll find that it's pretty dynamic and it's a little bit chaotic because bonds can break from one molecule and then it can form a bond with another molecule that's nearby and then break again and then form maybe another bond with maybe that's the original water molecule. So this is constantly happening, breaking and reforming, breaking and reforming. And a bond is broken and reformed a few trillionths of a second. So this happens extremely rapidly. So it's always breaking and reforming, very chaotic, unlike that of ice. And so we all know that when water gets cool enough, it forms these really beautiful crystalline structures. And this is showing that just that, where you can see these snowflakes forming, and sometimes you get ice forming on like your window. You can see these really pretty crystalline structures, and it's all because of the pattern that ends up forming because of the hydrogen bonds. Okay, so next important property is that water actually has that property of cohesion. And so cohesion, simply put, is when one water molecule is attracted to another water molecule. So it turns out that water is really sticky. And the reason why it's sticky is because of the hydrogen bonds, again. So this hydrogen bond, you can see this pattern emerging that hydrogen bonds are really important in kind of dictating the properties of water itself. So these hydrogen bonds can form between water molecules, and this enables water to become really sticky. So water molecules like to stick with each other. And if you ever look at the surface of a glass and you try to fill, or I shouldn't just say the surface of glass, but if you take a glass of water and you fill it all the way up to the rim of the glass, and then after you get to the rim and you slowly add maybe like a drop at a time, it won't overflow it right away. Instead, what you'll see is like this mound of water, like this bubble of water that forms at the rim. And the reason why it doesn't spill over is because water is sticky, because of that cohesive property. So the water molecules want to stick together and they don't want to let each other go, in a sense. And this can create what's called surface tension. And surface tension is the ability of that surface of the water to maintain its shape. Because water is so incredibly sticky, it actually will provide a good amount of tension at the surface. And this property, mosquitoes actually can take advantage of this property. So if you've ever walked by a natural reserve or maybe a lake or a pond, you can sometimes see mosquitoes, especially in the summertime, land right at the surface of the water and they don't sink. And the reason why is because of the high surface tension that exists at the surface of water. All right. The next property is something called adhesion. Now adhesion and cohesion play on this same property of water in the sense that they are both talking about water being sticky. So adhesion really refers to when one water molecule sticks to something else that isn't water. So we say sticks to maybe an organic substance, such as maybe like a paper towel. Like if you're ready to clean up something, you might have spilled some water on a table and you want to clean it up. The first thing you'll do is get a paper towel and start, wiping up that water. And the paper towel, you'll find, is pretty absorbent and can absorb that water. And the reason why is because of adhesion, because water can bind to organic material really easily. Why do you ask it can do that? Well, because water is polar. So water being polar is able to bind to other organic material. When we think about how water moves up the tissue of trees, this specifically, if you look at barks, takes place in xylem cells. So xylem cells are basically cells that push water from the roots all the way to the rest of the tree, such as the leaves of the tree. And if you take a closer look here, and if you were to examine how this reaction is working, you'll find that it's playing off that idea that water is sticky, because you see adhesion taking place right here where water is binding to the organic material, and cohesion is also working in allowing water to transfer up the xylem cells. Because cohesion is the idea of when water molecule binds to another water molecule. All right, and those are the 5 major properties of water. I hope that was helpful, and keep studying.